Hello there, Mr. Sutton here, bringing you the AB Calculus 4-8 classwork solutions on mean value theorem. On this problem, they're saying the mean value theorem guarantees the existence of a special point on the graph of square root of x between 0, 0 and 4, 2, and they want the coordinates of this point. Well, what special point are they talking about? The mean value theorem says that if we have a function that is differentiable on an open interval, like from 0 to 4, that means that somewhere on that interval there's an x values where the instantaneous rate of change equals the average rate of change over the whole interval. So, do we have differentiability for the square root function on 0 to 4? We do. That is a smooth curve between 0 and 4 for x values. It's not differentiable everywhere before 0, but afterwards we're differentiable. So moving ahead then, we can say that for some value on this interval, the average rate of change and the instantaneous rate of change are the same. So to figure out where that value is, we need to calculate both of these things. Average rate of change, we'll be able to get an exact number. So that's just going to be 2 minus 0 over 4 minus 0, which is 2 over 4, or 1/2. For the instantaneous rate of change, we don't know the exact value, but we know that we want it to equal 1/2. What we can do is take the derivative of y equals the square root of x. So that's going to be, for f prime, we're going to have 1/2 x to the negative 1/2 using our power rule here on x to the positive 1/2. All right, so we know that this and this need to equal each other. Now, going ahead and solving for this algebraically, we can divide both sides by 1/2 or multiply by 2. And then I know that if x to the negative half equals 1, then x has to be 1. So then what's the y value? Because they have a whole point here. The y value is just the square root of 1, which is also 1. So that gives us the point 1, 1, choice B. For this question, we have the function x cubed minus 3x squared, and we want to know all the c values that satisfy the mean value theorem on the interval from 0 to 3. Now, the mean value theorem says if you have a function that's continuous on a closed interval and differentiable on an open interval from 0 to 3, which this function is because it's a polynomial, so it's differentiable everywhere, that means that at some x value on this interval between 0 and 3, the instantaneous rate of change there equals the average rate of change for the whole interval. So just to write out the conclusion of the MVT for this, we're saying basically that A-rock equals I-rock for some x value on 0 to 3. Now, it's very important to note that I did not use brackets on this. The mean value theorem only guarantees the c value between the endpoints, 0 and 3. 0 and 3 themselves do not count for satisfying the mean value theorem. So that means that any answer choice that has a 0 and 3 in them, because we can't include 0 or 3 as c values, any answer choice with one of those actually can get thrown out right away. So for example, A, C, D, which has both of them, and E also has 3, so it gets thrown out. That leaves us with just answer choice B. This is kind of a picky point, this open interval business for the conclusion, but if you understood it, you got this answer choice in a few seconds. All right, but let's do it the longer way just so you can see that in progress here. So for the average rate of change, we've got f of 3 minus f of 0 over 3 minus 0. So that's going to be, let's see, f of 3, that's 27 minus 27, or 0. F of 0 also comes out to 0. So you've got 0 over 3, which is just 0 for the average rate of change. Instantaneous rate of change, we're just taking the derivative of x cubed minus 3x squared, which is 3x squared minus 6x, using our power rule. Now we're going to set I-rock and A-rock equal to each other and solve for the x value that makes that true. We can factor a 3x out here, leaving us with x minus 2 inside. And then, setting each of these equal to 0 and solving, we've got 0 and 2 for the x values. But now 0 is a border value. It's an endpoint. It's this endpoint here. So that means we can eliminate 0. That doesn't count for satisfying the MVT. And 2 only is our answer, which is what we got before, choice B. On this problem, f is the function defined as x plus ln of x. We want the value of c for which the I-rock at some c value is the same as the average rate of change of f over 1 to 4. So basically we're asking for a c value that satisfies the mean value theorem. So for this we need to first figure out what f prime is. That's going to be 1 plus 1 over x. Next we need to set it equal to the average rate of change, which is going to be f of 4 minus f of 1 over 4 minus 1. And I'm going to do this on the calculator because that's not an exact value anyway. I mean, doing ln of 4, that's going to be some nasty decimal. And if you look at the answer choices, this definitely looks like it needs a calculator. So here's what I've entered in my y equals on the calculator. For y1, I put the original function because I'm going to need to use it down here for average rate of change. For y2, I put my derivative in there. And for y3, I put the average rate of change, f of 4 minus f of 1 over 4 minus 1. And for this fraction, I did alpha y equals. For the y1s, I did alpha trace if you want to get those real quickly. Another thing you can do to make your life easier on this, since they told you the interval, 1 to 4, go to Window and actually make that your x min and x max, and then do a zoom 0, zoom fit. And that'll give you the perfect window on what's going on with these two functions. So there's your derivative. And here is your average rate of change, which should be a horizontal line because it's just a constant. Next, we're going to go to second calc, second trace, this right here. And then we're going to pick option 5, intersect. And then just press enter 3 times. And we get the magic C value of 2.164. So there's my graph, there's my intersection. C has to be 1.164, which is going to be answer choice C. On this problem, we are giving a table of values for x and the output for x. We're told that this is a twice differentiable function, and we want to know which of the following must be true. So we've got no critical points on the interval from -1 to 5, f prime equals 8 somewhere, f prime is positive, f double prime is negative, and no points of inflection on this interval. So there's a lot of these that look plausible. If you look at what's happening with my y values here, we're increasing the whole time, and not only that, but we're also apparently increasing by a decreasing amount the whole time. So it looks like we're increasing the whole time, which means it looks like there's no turnaround spots, so that would seem to suggest there are no critical values. However, we don't know what's going on between these table entries that they gave us. I mean, for all we know, this graph might turn around somewhere between 0 and 3. And even if it doesn't turn around, you don't need to turn around to have a critical value. So choice A, we don't have enough information to make that conclusion. Choice B, we don't have enough information at this point to talk about specific values of the derivative, but we'll come back to this one because we can actually do something for this answer choice. Choice C, we don't have enough information to conclude that this graph is increasing for all values in the interval from -1 to 5. It looks like it is, but again, how do we know what's going on in between the table entries? Same thing for D, although it looks like this is concave down the whole time, increasing at a decreasing rate, we don't know what's happening in between. And we certainly don't know whether or not there are any points of inflection in between our table values. So because of the lack of information, we can't prove A, C, D, or even E. Now, how about choice B? Choice B is the only choice that doesn't make claims about the entire interval. It's just saying somewhere the derivative equals 8. Well, the mean value theorem says that if you have a differentiable function on some interval, then somewhere in there the average rate of change over the whole interval equals the instantaneous rate of change. So let's find the average rate of change between -1 and 5. That's going to be 18 minus -30, so plus 30, over 5 plus 1. So that's going to be 48 over 6, which happens to equal exactly 8. Since our function is twice differentiable, meaning that at the very least it's differentiable on the interval from -1 to 5, that means that by the mean value theorem, we are guaranteed that the instantaneous rate of change must equal 8 somewhere on this interval because that's what the average rate of change is. So choice B then is going to be true by the MVT, and again, we have differentiability to complete the picture here. For this question, we're given a polynomial of degree greater than 2, and we're told if A doesn't equal B, then f of A equals f of B equals 1. So basically, we have two different x values, and we're getting the same height. So we're starting and ending at the same height at two different x values. Based off of that, which of the following is true for at least one value of x between A and B? So we're told about f of x, f prime of x, f double prime of x, all equaling 0. Which of these are true? And it's possible that they're all true or none of them are true, or somewhere in between. So let's deal with option number 1 first. This is basically saying that we have to either touch or cross the x-axis at some point. Is this true? Well, if we're starting and ending at the same height, what if that height is above the x-axis and we're going above and then back down? We don't actually have to cross the x-axis at all to hit the same y value twice. So that eliminates anything with option 1 in it. For example, B, D, and E. Those are all gone because option 1 doesn't have to be true. Option 2, we'll come back to that one in a bit. It turns out that it's either option 2 is true or none of them are true. Let's look at option 3 just briefly so we can eliminate that one, even though we don't need to, based off the answer choices. So this is saying that we have either an inflection point or something pretty close to it. But that doesn't have to be true either. We don't have to have an inflection point. This could just be a parabola part of a bigger curve. Like if you're going up and then back down, you're going to be concave down, you're going to be negative f double prime that whole time, not 0. So this doesn't necessarily have to be true either. So now let's turn our attention to option number 2. Now this one is talking about the derivative equaling 0. Whenever we're talking about f prime equaling a certain value, we might want to think about using the mean value theorem. Does it apply in this case? They told us this was a polynomial function. So because it's a polynomial, that means it's differentiable everywhere. So that means the mean value theorem does apply wherever we want it to on this. What that means is that the average rate of change from A to B is going to equal the instantaneous rate of change somewhere on the interval between A and B. So let's figure out that average rate of change. So in general, we have 2 points, A, 1 and B, 1. Taking the average rate of change now, that's going to be 1 minus 1 over B minus A. And I don't know what B and A are, but we don't care as long as they're not the same thing. And they told us A and B are not the same, so we know that B minus A, whatever it is not 0. 1 minus 1 is 0. We have 0 over something that's not 0, so that's 0 overall. That means that there must be some x value between A and B where f prime equals 0, which is saying that option B is actually true. So that means, or option 2 is actually true. So that means choice C then is going to be our answer, 2 only. For this problem, f is a differentiable function on the interval from 1 to 10, and they're giving us different function values of f. Based off of these, we want to know which of these statements has to be true. All right, well, let's look at the first statement. F has at least 2 zeros. To figure that out, since this is a differentiable function, that means it's a continuous function, which means the intermediate value theorem applies here. So we're starting at the point 2, negative 5. Then we're going up to 5, 5. So we're going from negative to positive. Then we're going back down to 9, negative 5. We have a continuous function with 2 sign changes. That means we must have crossed the x-axis at least twice. So because we're continuous with 2 sign changes, the IVT tells us that we have to equal 0 at least twice, so option 1 has to be true. For option number 2, they're saying the graph of f has at least one horizontal tangent. Now what they're saying here is that somewhere on the interval from 1 to 10, f prime equals 0. The instantaneous rate of change is 0. That's what this horizontal tangent is getting at. This ends up being true for the following reasons. Since we have a differentiable function, the MVT, the mean value theorem, applies here, which means that the average rate of change over 1 to 10 is going to equal the instantaneous rate of change somewhere on that interval. Let's find the average rate of change. And actually, we're just going to go with the points that we have here, which are 2, negative 5 and 9, negative 5. So this is going to be negative 5 minus negative 5, or plus 5, over 9 minus 2 for the average rate of change. And we could try to do average rate of change between 1 and 10, but we don't know what's going on at 1 and 10. We do know what's going on at 2 and 9, so that's why we're using this more limited field here. So this is going to end up being 0 over 7, so that's 0 overall. That means that there's some c value between 2 and 9 at which the instantaneous rate of change is 0, which is to say that we have at least one horizontal tangent line on there. We might have more, we don't know, but we've at least got one. So that means option 2 must be true as well. So this means that we have to have an answer choice with options 1 and 2 in it. That narrows it down to answer choices C and E. So it all comes down to whether or not number 3 is true. So for 3, for some c value between 2 and 5, the output for the function is 3. This is another intermediate value theorem question. So we have this interval right here between 2 and 5 where the y values are going from -5 to +5. To do that, they must have passed through 3 at least once. You have to go through 3 to get from negative to +5. And you actually have to go through it again to get from 5 back down to -5 for a continuous function. So all 3 of these end up being true, which means E is our answer. For this problem, we have a function that is continuous over -2 to 2, and f of -2 and 2 are both 0. If there's no c where in this interval where f prime of c is 0, we want to know which of these statements has to be true. And these are all talking about various properties of f prime for some k value on the interval from -2 to 2. So intuitively, what's happening in this problem is we are starting and ending at the same height. But we're doing it without having a horizontal line, a smooth turnaround, or discontinuities. How do we know we don't have these things? Well, if f prime does not equal 0 anywhere, you can't have a horizontal line because the slope on that is always 0. If f prime is not 0, that means there's no smooth turnaround anywhere where we could go up and get back down to the same spot. And the only other way to go up or down and get back to the same height, which is what's happening here if you're starting and ending at 0 for the height, is you either need a discontinuity or some other non-differentiable spot. But they told us the function is continuous, so we can't have any discontinuities either. So what does that leave? Well, the only way to go up and get back down without discontinuities or smooth turnarounds is if you have some weird non-differentiable spot like a corner or a cusp. And either of these possibilities mean there is some k value on the interval from -2 to 2 where the derivative does not exist. So choice E is the logical choice based off of our intuition up here. If you want to do it a little bit more systematically, we could start by looking at the mean value theorem, which says that if a function is differentiable, then a-rock and i-rock equal each other. Let's find a-rock for this. So that's going to be the y values 0 minus 0 over the x values 2 minus -2. So the average rate of change, big surprise if you're starting and ending at the same y value, is 0. So that means that the mean value theorem guarantees there is some c value between -2 and 2 where f prime of c is 0, where the derivative is 0, if the function is differentiable on -2 to 2. Looking back at the problem, they said there is no c value where f prime of c is 0. So since the NVT would guarantee it existed if we had differentiability, that means we must not have differentiability. F is not differentiable on the interval, which means there is some place where f prime does not exist on the interval from -2 to 2, all of which leads us to answer choice E. Now looking at the other answer choices, just for really eliminating them, A and B are talking about the derivative always being positive or negative. C is saying it always exists. D is saying it exists, but f prime is not continuous. So all of these are wrong for the simple fact that we know the derivative does not exist somewhere on this interval, and these all imply that it does exist everywhere. On this problem, we're given a differentiable function with the following table values for the original function. We're told the function and its derivative are strictly increasing. We want to know which of the following could be f prime of 3. So the key on this one is that they gave us a differentiable function. That means our mean value theorem applies, and we can make conclusions about instantaneous rates of change based off of average rates of change. So our first attempt at this problem might be to figure out the average rate of change between 2.8 and 3.1, because the instantaneous rate of change of 3.0 at that spot should be close to that average rate of change. So if we do that, So here we go. I've got 48.05 minus 39.2. Those are my y values. Divided by 3.1 minus 2.8. That comes out to 29.5. Yeah. Well, so 20 is probably way too far off. But we've got a few answers here. I mean, I'm thinking everything from C through E that's pretty close to 29.5. I mean, at the very least, we can't really choose between C or D. So we need to dig a little bit deeper on this one. So I'm going to use the mean value theorem in a different way. My strategy on this, I'm going to figure out the possible f prime between 2.8 and 3.0 using the mean value theorem. Then I'm going to find another possible f prime between 3.0 and 3.1, again using mean value theorem. And then I know that the f prime at 3 has to be somewhere between those other two f primes. So here's my reasoning. Since the mean value theorem applies everywhere on here, that means that there is some a value between 2.8 and 3.0 such that f prime of a equals the average rate of change from 2.8 to 3.0. That average rate of change is going to be 45 minus 39.2 over 3 minus 2.8, which I will now do on the calculator. And on the calculator, that ends up giving me exactly 29. Okay, great. So what that means, since this is a strictly increasing function, or since f prime is strictly increasing, that means that the true value of f prime of 3 must be higher than 29. Can't be exactly 29 because the f prime just keeps going up. So that means we can already eliminate A, B, and C. So now it's down to D or E. All right, so let me pick a B value now. There is some B value on the interval from 3 to 3.1 such that the IROC at the B value equals the average rate of change on 3 to 3.1. So that is going to equal 48.05 minus 45 over 3.1 minus 3. And let's see what the calculator has to say about that. So plug in those numbers in here. I end up with 30.5. Since this is a strictly increasing f prime, that means that the true value of f prime of 3 has to be less than 30.5. So overall, since f prime is strictly increasing, f prime of 3 must be strictly between 29 and 30.5. It can't be either one of them. It's got to be between them. The only answer choice that is between them is D, 30. For this problem, we have a function that's continuous on the closed interval 2 to 4, and we have the points 2, 10 and 4, 20. Which of the following does the IVT guarantee? All right, so the intermediate value theorem in general says that if we have a closed and continuous interval here, we are guaranteed to hit all the y values between 10 and 20 if we are between the x values 2 and 4. So looking at our answer choices, choice A, f of x equals 13 at least one time in the open interval from 2 to 4, well, that's going to be true because 13 is between 10 and 20. So the IVT guarantees that this will happen. So we could already pick choice A, but let's look at the other answers just to be on the safe side. So choice B, f of 3 equals 15. Well, the IVT guarantees we're going to hit 15 at least once on the interval between 2 and 4, but it doesn't specify at what x value that's going to happen. We don't know if it happens at 3 or 2.5 or whatever. This one then is too specific, so we can't guarantee this. The next one, f attains a maximum on the open interval from 2 to 4. Well, the IVT doesn't say anything about maxes and mins. That would be the extreme value theorem. And the extreme value theorem requires us to have a closed interval, not an open interval. So choice C can be eliminated for multiple reasons. Next one, f prime equals 5 at least once in the open interval from 2 to 4. Well, now we're talking about the mean value theorem. And the mean value theorem, regardless of what this slope actually comes out to for the average rate of change, mean value theorem requires differentiability. They did not tell us the function was differentiable, only that it was continuous. And then finally, choice E, f prime is positive for all x's on the interval from 2 to 4. Well, we are increasing at some point to get from 10 to 20, but we might be increasing, going back down, increasing again. We can't guarantee that we're increasing the whole time, because again, we could go up and then down again. So by process of elimination, choice A.